Hey guys, today we're going to do another simulation example. This is a fast food restaurant collecting a Happy Meal type of thing, in this case Jolly Meal. This is section 5.1 and it's on page 4, so right in the middle of the page. What we're going to do is, remember, there are 5 things that you have to go through when you're modeling a simulation. Model, single trial, statistic of interest, repeat for large number of trials, and then conclusion. So I'm going to go through those. This example is a little bit different from the ones that we've done. In fact, they're all kind of different. You have to imagine how you're going to actually simulate this. So we've got the local McDiggins fast food restaurant promoting their latest collection of Jolly Meal toys, and here they are. They're actually pretty interesting. One of them is an Irish accent. One of them is a fart machine, hillbilly teeth, and trick or turd. So your goal is to collect all 4 of them. And so the question is, how many Jolly Meals do you have to buy in order to have all 4 of them? So in this case, this is an example of a geometric simulation, or geometric probability. And the reason for that is because you don't know how many you have to buy. You are doing something until a desired outcome is reached. And in this case, you are going to continue to buy. It's an unknown number of Jolly Meals that you have to buy until you have all 4 of these toys. So I'm starting with the model. And a lot of times this is the hardest part. So I've got a random number generator. I'm going to use my calculator. What am I going to generate numbers? What am I going to assign as each number? I'm doing this until I get what. My suggestion here would be to number these meals. This one is 1, this one is 2, this one is 3, and this one is 4. And what I'm going to do is I'm going to generate random numbers 1 through 4. Repeats are allowed because obviously if you go to this McDiggins fast food restaurant and you purchase a Jolly Meal and you get the Irish accent for the second time, that's likely to happen. So we want to know how many times do we get repeats and stuff like that. So we don't want to ignore repeats. We want to actually use them because it represents going to the store and buying another Jolly Meal and getting the same toy you already had. So what I'm going to do is randomly generate numbers 1 through 4, and I'm going to see how many times I have to generate a number 1 through 4 to get all 4 of the numbers 1 through 4. So what I've done is I've written down what the model should look like, and the model is exactly how are your numbers going to represent everything and how are you going to do this. So I'm using a random number generator, and I'm only generating numbers 1 through 4, and I'm stating specifically what each of the numbers stand for. Each of the numbers stand for each of these that I have labeled up here. And I also added a note, just since these are your notes, make sure that you have designated this one as a geometric probability one, which is different from the other 2 examples where we knew exactly how many numbers we had to generate. In this case, we don't know how many numbers we're going to generate, but I'm going to continue generating numbers until, big key there that it's geometric, I have collected all 4 toys. So that's what my model looks like. Next thing is the single trial. And in that single trial, what I'm doing is each time I'm using my calculator and I'm pressing buttons and I'm generating numbers, what does that look like? So here's what my single trial looks like. I am going to continue hitting random number on my calculator until, and it's generating numbers 1 through 4, until I have at least one of each numbers 1 through 4. And now most likely I'm going to get some repeated toys in there. That's okay. What I'm curious is, how many Jolly Meals do I need to buy in order to collect all 4 of these toys? Next thing I'm going to do is define the statistic of interest. Remember, the statistic of interest is defining exactly what we're looking for once we do each trial. So once I have my random number list and it's like 4, 3, 3, 1, 1, 4, 2, I have to count how many of those numbers I generated until I had all 4 of the numbers 1 through 4. And I'm putting toys here in parentheses just to remind myself that that's what those numbers 1 through 4 actually stand for. Okay, so here's the hard part. What I have to do is actually go to the calculator now, and what I'm going to do is repeat this for a large number of trials. And remember, I'm going to show 10 trials showing all my numbers for the first 5, and then just the statistic of interest for the next 5. So I'm going to do 10 total. And so just so you know, because I know a lot of you have your own 89s, just to make sure, this is what you're going to have to do on the test, is I'm going to have you seed your calculator. And what that means is we're all going to get the same numbers. And we've talked about how it's not exactly a random number generator then, but that helps me know that you're not just making up random numbers, that you actually know how to use the calculator here. So what I've done for this problem is I seeded my calculator at 12. So go ahead and do that to your calculator. Remember, go into the catalog and just look up rand seed and type in 12, and then it'll say done. And therefore, when you're generating these numbers with me, we will all get the same numbers. Okay, so what I'm going to do is I'm going to show the numbers for step number 1. What I've done is I have typed rand int 1, 4, close the parentheses, and then the first number that it shows me is 4. So I'm going to actually write these numbers down as my calculator gives them to me. The next one is 2. The next one is 3. So I have the first 3 toys so far. So now all I'm looking for is a 1. And once I get a 1, that's the last toy that I need, then I'm going to stop. Next number, unfortunately, is 3, so I got a repeat toy. And then I got a 1. That means I had to buy 5 of the meals in order to collect all 4 toys. So I'm going to do this again for the second one. Again, and you can do this with me. You should be getting the same numbers that I did if you seeded your calculator at 12. Same thing, next one, the first one they get is a 1, followed by a 4, then a 2, then a 3, and boom, it only took me 4 tries to get all 4 toys. Number 3, I get a 1, a 3, a 2, and a 2, and remember I have these defined as like the fart machine, the Irish accent, whatever, above, so you know exactly what toy goes to which number. 1, 1, 4, so there, I was just looking for a 4, and I finally got it, and that gives me a total of 7 Jolly Meal toys. So our statistic of interest is this number here. This is so that I can check your work, but you're listing all of these out. I'm going to do 2 more. And here's what those look like. So again, be checking these in your calculator with me. As I was on trial number 4, I got 4, 3, 3, 1, 4, 1, 1. This whole time I was looking for a 2. And finally I got a 2 on my 12th try, which means it took me 12 Jolly Meals in order to end up with all 4 toys. This one, 3, 4, 3, 4, 2. Now I'm just looking for a 1, and I didn't get a 1 until the 9th trial. So that's why I wrote down a 9 there. And so once I've shown the work for 1 through 5, this is kind of the work that needs to be shown. For 6 through 10, you can just look in the calculator and then tell me how many times you had to hit enter until you got all of the toys. You don't have to list out each number for the next 5. So I'm going to do that next. So here's what all my numbers came out as. So for trial number 6, that was by far my longest one. I had to keep hitting enter 16 times until I had gathered all 4 of the numbers. Number 9, again, I hit 1, 2, 3, 4, and I gathered all 4 of them. So this is what my statistics look like for the repeat for large number of trials. Last thing I need to do is conclusion. I need to come up with an estimated average. So the question being asked is, on average, how many times do you need to buy a Jolly Meal in order to collect all 4 toys? So what I'm averaging together is this number, this number, this number, this number, this number, and all of these. So I'm averaging them all up, and I know it's kind of stupid, but make sure you're showing your work. You're adding up all of these numbers, 5, 4, 7, 12, 9, blah, 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 dividing by 10 because I did this 10 times. That gives me a whole number of 9. What does that represent? Remember, that's the average number of meals that I need to buy in order to collect all 4 toys. So kind of a bad deal for me, kind of a good deal for the restaurant, because if you want 4 toys, you got to buy the number of meals 9 different times on average. So remember, we write a conclusion in context. A couple important things about the conclusion, just to remind you, according to our simulation, that's according to this up here. And so it's important that, remember how we seeded our calculator to 12? If you would have seeded your calculator to something different, these numbers would have all been different, and you probably wouldn't have gotten 9. Maybe you would have gotten something close to it, like 10 or 8 or 12 or 11, I'm not sure. But according to our simulation here that we did, the average number of Jolly Meals needed to be purchased. The goal was to obtain all 4 toys, so that's inserting the context into the conclusion, is about 9 meals. And I'm using the word about because this is according to our simulation. And you guys know that it probably wouldn't be exactly 9 if I used a different random number generator. If we all did this at a different seed, that would probably be a different average. That is all. Just remember that this is our geometric probability example, so make sure you have this kind of starred or asterisk because we haven't done one of these in class yet, but looks a little bit different. Remember to go through all 5 of these when you are showing all your work for a simulation problem. Thanks for watching. Bring your questions to class tomorrow. See you later.